Okay, algebraic techniques. This is from a challenge exercise from the Maths in Focus. So there are about 15 questions and it's going to be quite a long session. So make sure you have a bit of a break in between. Okay, let's start. First, write 64 to the power of minus 2 over 3 as a rational number. Now, rational number is the fraction, okay? Something that we can change into fraction. So we will expect the answer to be fraction. Okay, so before I start, I'm just going to show you some little trick that this is a 64 and I want that to be 2 to the power of something or 3 to the power of something. I want something to be power of so that it'll make it a little bit more simpler. I'm going to use log. So I'm going to put this as a note. So I'm going to put log 64, and because it's even number, I'm going to try it with base of 2 and see what I'm going to get as a power. So what I'm going to do, I'm going to show you in calculator. So I'm going to use fraction button there, and I'm going to use log 64 and then log 2. It gives me 6. That means power of 6. This is the power, okay, index. So what does that really mean is the power of the base is 2. So that means 64 is 2 to the power of 6. Okay, so this is a little sort of shortcut. And I'm going to rewrite this as a 2 to the power of 6 to the power of 2 over 3. Okay, now remember, power to power, you times it. 6 times minus 2 over 3. Now if you do that, you'll get 2 to the power of 4, because 2 times minus 2 is power of 4. Now this is not a fraction form yet, so I'm going to rewrite this 2 to the power of 4, yeah, because that is something 1 over something, so reciprocal. So that will be 1 over 2 to the power of 4 is 16. So the answer is 1 over 16. Okay, next one. Show that. Now, highlight or underline this. Show that, basically think of as left-hand side is right-hand side equals. Okay, so that's what we are trying to do here. So that we prove it to be equal to match up with the right hand side. Okay, I'm going to change the color just because I feel like it. So left hand side, I'm going to rewrite the question. Plus 2. So make sure that is the smaller, because the power is k plus 1, not power of k and the plus 1. Okay, so I'm going to expand this one to be 2 times 2 to the power of k minus 2 plus 2 to the power of k plus 1. Now that really has power of 1 there, isn't it? So when you have a same base, you can add the power, but we don't know what k is, so I'm going to put it like that. Okay, minus 2 plus 2k plus 1. Now this is almost like algebra, okay? So it's like a plus a or x plus x. So I'm going to write 2 of these, so that would be k plus 1 minus 2. Okay, all right. Now I'm just have to check. It's like a middle process report or some sort. So I'm going to check this, and I'm going to check, because our goal is to make it look like this. Now, I almost there. It looks like it's almost there. If I take the 2 out as a common factor and put the rest inside the brackets, there you go. I've got exactly the same as my right hand side. Excellent. Now, therefore, left hand side equals right hand side as required. required from the question. So make sure you put that as your final. Okay, keep moving on. Oops, blank. Okay, question 3. Find the value of a over b cubed c squared in index form. I'm going to highlight this just because I've got a highlighter right next to me. You can underline if you like. Okay, so, and then it's all given. So all I have to do is just substitute in there. Okay, so my expression is this. I'm just going to rewrite this and I'm going to put everything in there. So a was 2 over 5 to the power of 4. b cubed, that's just the b. So what I'm going to do here is like that. Okay, and then I'm going to do the same thing with the c. That's a c, but it has to be squared. Okay, now it looks a little bit messy, but it's not too bad. It's not too bad. Let's simplify it, sort of tidy it up a little bit. So what I've got here is minus 1 over 3 to power of, what is it? 9, isn't it? You times by 3 times 3. And same thing happens. 2 times 2, 4. Okay, so far so good. Next one I'm going to do is this. I'm not going to do 2 to the power of 16 or 5 to the power of 4 something. I'm just going to simplify this a little bit. I know that it's a power of, it's odd, so I'm going to keep that negative. So 1 to the power of 9 is 1. 3 to the power of 9 times 3 to the power of 4, 5 to the power of 4. Okay, so that's what I've done. Now in here, I'm going to go a little bit further. Can I do this? I'm going to put it together. Minus 3 to the power of 4, because minus 1 times that is that, and then times 4. Now if that's going to be times by, it'll be flip. Okay, so if I'm going to flip that, will be like that. So I just want to give you a little bit of a quick revision of this. So if it's something and it was, say, b over c, yeah, it means a divided by b over c, isn't it? Okay, and then it'll be a times, then you'll flip c over b. So that's what I've done. So a is the top numerator, and this part was this, b over c. And when I times it, it flips. So memorize that process. And I can see something I can cancel here. I can cancel this. And I can simplify this, okay? Because that's like a 9 take away 4. So I'm going to write that. And then minus, I'm going to keep that minus. 9 take away 4, isn't it? Because it's divided by. So what I've got is 5. Okay, so my final answer is 2 to the power of 4 minus, I'm going to put the minus in the front, times 3 to the power of 5. Because what does the question say? Question says find the value in an index form, not the actual whole number, index form. So I found the value in index form. There you go, done. Question 4. Okay, there's 3 parts in the question 4. So I'm going to do that now. Okay, so expand and simplify. So you've got to do two things here. You expand it first and then simplify if you can. So let's do that. So I'm going to expand this times it. So it'll be 4a squared b minus 8ab squared. Now it's a good idea to pause it and do it yourself and then check it if you need to. Now be careful with this, minus minus becomes plus. And I'm going to use that. That's the same family. Squared b minus 8ab squared plus 6a cubed. Okay, now you probably want to have a bit of urge to, I don't know, if you're like me, you want to do something like take a 2a out and then simplify a little bit further or factorize a little bit like that. That's still okay. And then just leaving it that will be okay too, because by doing that it's not going to really make huge difference anyway. So next one. This one looks like difference of two squares, isn't it? Like a plus b, a minus b equals what? A squared minus b squared. Okay, so that looks like that. So what I'm going to do, I'm going to do just that. Okay, so what's that going to be? Y to the power 4, 4. Done. That was a simple one. Next one. Okay, so that looks like power of 3. Ooh, what am I going to do? It's okay. What I'm going to do is make it like this. So what I've done is 3 is a times a squared. Okay, why? Because I want that to, we know the perfect square, so I can expand that. So I'm going to leave that one, it is, and I'm going to do the perfect square, 4x squared, so remember that, and double of the product of two vectors. So it's going to be 2 times 2 times 5, which is 20x, plus square of 5, 25. Okay, so I've done that, and I'm going to expand this. Now you can do like that rainbow thing, expand, but what I'm going to do is this. I'm going to do 2x times the whole thing minus 5 times the whole thing. I found it's just easier. It might be a little bit longer, I'm not sure, but what I'm going to do is that I'm going to make less mistake, hopefully. So that's what I'm doing this way. It doesn't really matter which way you do it. And then I'll do expanding, you know, like that rainbow thing. This is upside down, rainbow looks like it. So I'm going to do x cubed minus 40x squared. Take your time when you do this because you might make a mistake. 20x squared plus 100x minus 125. And don't forget to use a calculator. If you can't think straight or fast, use calculator. It's better to use a calculator and get it correct than do it fast and get it wrong. Okay, and then I'm going to that's the same there. So I'm going to just cross it off so I don't get confused. So I've done that, and I'm going to do this one, which 150 minus 125, the last. Okay, so that's done. Excellent. Now, question 5 is saying, find the value of x plus y with rational denominator if x equals root 3 plus 1 and y equals 1 over 2 root 5 minus 3. Okay, so that's what we got to do. It's not too bad. Yeah. So I'm going to do x plus y. So that means x plus y here. I'm going to go root 3 plus 1, that's my x, plus 1 over 2 root 5 minus 3. That's what I've done, x plus y. Okay, now here I need to change something in this side, okay? Because this is irrational, so I'm going to rationalize the denominator here by using conjugate pairs. 5 plus 3, 5 plus 3, okay? So I'm going to do this first. So I'm going to continue to carry out the x, and what I'm going to do here is what? 2 root 5 squared minus 3. So that's the difference of 2 squared. That's the whole point of using difference of 2 squared, so we can get rid of the square root. On the top is that. Okay, so I'm going to continue with that. 2 root 5 plus 3. Now, what's this going to be, guys? What's that? 2 root 5 squared. That just means what? 2 root 5 times 2 root 5. Or you can just think of it as 2 times 2 times 5. Because 2 times 2 times, if you square that, it would be 5. So, what do we get here? Will be 20 minus 3 squares, 9. Root 3, I'm going to continue. 2 root 5 plus 3 and 11. Excellent. And then I'm going to make the 11 as my common denominator. So it'll be 11 root 3 plus 1 plus 2 root 5 plus 3. And I'm going to expand this one. 11 root 3 plus 11 plus 2 root 5 plus 3 over 11. And tied it up a little bit. Plus 2 root 5 plus 14 over 11. Voila, that's it, done. Okay, so next one, question 6. Let's have a look at that. Okay, simplify that. That's not too bad, but I'm just going to do something, a little bit of preparing before I do rationalizing denominator. So what's happening here is this one. I'm just going to show you a couple of ways of simplifying this. First, you probably, it will be the easiest, will be think of factors of 54 with square numbers in it, because the whole point is to simplify, is to get something out of square root. So I can think of this as 6 times 9, okay? So that means 3 squared times 6, isn't it? Because 9, so that square can go out. There you go. That's what I got. Or second one is one that is like upside down division, 54, and you divide it by prime numbers, start with like a 2, 3, 5, something like that. So 54, I'm going to safe, it's an even number, so I'm going to start with a 2, and 27, and I'm going to with a 3, 9, 3, 3, and I'm going to pair them up so that I'm going to have a square. So 54 equals what? 3 squared times 6, which is exactly the same as that. So I can do 54 equals 3 root 6, same. So this is something that you can use and practice. So I'm going to go 2 root 3, 7 root 6 minus, now I know that root 54 is 3 root 6. Beautiful. So that will give me 4 root 6. All I have to do right now is I'm just going to okay, simplify that. Root 3, 2 root 6. Now you can do this. Do you remember this? Root B is the same as A over B. Okay, so you need to, it's good to memorize all the little rules and formulas. So what do I get? I'll get 1 over 2, which is 1 over root 2. And I'm going to just times by root 2 to rationalize the denominator. I'm going to go 2 times 2, root 2, 2 over 4. Now, beauty of this question is you can do any way of you like. So, for example, from here, you could have done rationalizing denominator if you want to, by timesing it root 6, if you want. Okay, and then you get that. Or you could do this way. Now, root 6 is what? Root 6 is root 2 times root 3, isn't it? So I'm just separating root 2 times root 3. I can cancel that. I'll get 2 root 2, and then you times by square root 2 on the top and the bottom, and you will get the same. Okay, excellent. Next one. 7. We've got 3 parts in a 7. Again, this is going to be quite a long one. So have a break and come back, and I might actually finish after question 7 and continue, so I can have a break as well. Okay, so let's finish with this question 7. Factorize. A. X plus 4 squared plus 5 brackets x plus 4. Okay, that's not too bad. I can see the common factor here as x plus 4. And then I'll have left with x plus 4, one of them, and the 5. X plus 4, x plus 9. Done. That was easy. Part B. You see that? Ooh, that looks quite good to me as a sort of quadratic. Because if I do this, it looks almost like quadratic, isn't it? So I'm going to do, what's a factors? It's like a monic. Let's put y there so I won't forget. So factors of 6, that will give me, when you add it, it'll be minus 1, and times it minus 6. That's 2 and 3. So I'm going to write 2 and 3. And because its middle one is negative, the big one will get negative. Small one is that. So when I add this together, I will get minus y. And when I times it, I'll get minus 6 y squared. Okay, so that's done. So be careful what you do there. I need a bit of a thinking is required there. And last one, I'm going to do by grouping. So what's a common factor here? A squared. So if I take a squared out, get that. Common factor here, 4. I'm taking 4 out. Just be careful with that. It's a minor. We're taking minus out, so we're left with a minus. And then what's common factor? A squared minus 4. And it's not quite finished yet, because what's that? That's the difference of 2 squares, isn't it? So that's my answer. Now with this, you have to be careful from here to here. So think of this is like minus 8. So if I take, because to get plus you get minus minus, right? So when you take the minus out, one of the minus out, you still got the other minus left. Think of like that if you want to. Okay, well done. I'll see you soon.